Today we are going to see the splitting of peaks in NMR spectrum. Splitting of peaks in proton NMR spectrum. So kids, what happens if you have one spectrum in a low resolution? You have a different kind of picture. But if the same spectrum is taken in a high resolution, for example, let me explain this. I have this compound, so take out the data from data booklet and you help me to see. Look, this is H, this is H, this is H. Here it is. How many peaks for this arise in NMR spectrum, and what will be the chemical shift values? Okay, if I draw the spectrum here. So you are saying 3 peaks. If this is a 0 value for this, okay, chemical shift value, here is the chemical shift, parts per million. What will be the chemical shift value for these 3 peaks? What about these 3 protons, CH3? Okay, 0.9 to 1.7, good, Aries. So somewhere, let's say here, and 3 written on the top. What about this peak, these 2 hydrogens, they will have a different peak. Next to oxygen they are attached with the carbon, but carbon next to oxygen. So what will be the, what will be the value? 3.264. So here it was 1, here it was 2, here it is 3, here it is 2. What about this, Aris, the OH? This is not the carbon attached with the hydrogen. You have to go down in the table and see 0.5 to 6, right? And it's 0.5 to 6. Let's say year 4, year 5, year 6. So I'm gonna put it on the 5. Here it is. Is this the spectrum for the ethanol? 3 different hydrogen, 3 different chemical environments, their heights and everything. But now, kids, this is low resolution NMR spectrum. If I take the same one in a high resolution NMR spectrum, the same one, high resolution, you understand? I just think like I've zoomed in the same spectrum like this. When I zoom in, I see the same thing, but the peaks are now splitted up. Like I'm going to draw exactly underneath just to make you understand. All the peaks are at the same place, but these peaks are now splitted apart. The peak at the first peak, for example, this one, the chemical shift value is the same, just underneath here. But the peak is now looking like this. How many parts it is split into? 3. And this is known as triplet. How and why this is splitted and what is the criteria? Look at this. The splitting happens because these 3, they look like a bit far away, but actually they are not far away. The hydrogens, the hydrogens are very close to each other. So the peak, because of these 3 hydrogens, these 3 magnets, they are actually interacting with the neighboring magnetic field. So because of the interaction or the disturbance caused by the neighboring magnetic field, these peaks split up. So splitting takes place not because of the hydrogen of its own. The splitting takes place because of the neighbor. So if you are looking for this, if you are trying to find out the splitting for this, you are not supposed to look at these hydrogens. You have to look at the neighbor. So how many hydrogens in the neighbor of CH3? 2. And then the rule is N plus 1, where N is number of neighboring hydrogen. जितने भी neighboring hydrogen है उसमें एक क्या कर देना है, ऐड कर देना है, तो splitting आ जाएगी. So अगर इसकी splitting देखनी है कि these three splitted in how many parts, don't look at this, look at the neighbor. How many hydrogens in the neighbor? 2. So 2 plus 1, that's why the peak for CH3 will be at same chemical shift value but will be a triplet. Similarly, now if I ask you to look at the peak of CH2, will it be splitted? Yes. For the sake of splitting, you are not going to see this CH2. You are going to see its neighbors. Now it has two neighbors. One neighbor on the left hand side. How many hydrogens on the left hand side? 3. How many hydrogens on the right hand side? 1. But unfortunately, the oxygen, which is present between this and this, oxygen basically builds up a wall. It doesn't let the hydrogen to interact on the either side. Because of the lone pair of electrons and all that, we are not going into that detail. But oxygen के साथ और nitrogen के साथ जो hydrogen attach होते हैं, they can't interact with the neighboring carbons. Okay? Neighboring carbons की magnetic field से वो interact नहीं कर सकते. तो एक तरह से this side is nothing. Okay, so CH2 की अगर splitting देखती हैं, we have to look at the left side. How many hydrogens? So it is going to be splitted in how many parts? 4, known as quartet. So chemical shift value is going to be the same here, but it will look like this. Sorry. What is this? This is a quartet. This is triplet, and this is what? Quartet. Okay. And now, as for this one, I said it is not interacting with anybody in the neighbor. So neighbor is 0. 0 plus 1 is 1. So that is singlet. So this peak is going to look like the same as it was in the low resolution NMR spectrum. So here it is. So this is known as, because there is no one in the neighbor. OH, NH, ये neighbor में कोई नहीं होता. The height doesn't matter, right? So peaks will be given to you and you have to identify. So these are the quartet, triplet, and singlet. Now I'm going to let you write this. Okay, here you go. You have to fill this table, bacho. Yeah, I'm going to let you write this. Kind of explanation is here. Here it is. Splitting of the peaks. Now this splitting also has some ratio, but ratio is not in our syllabus. Neighboring hydrogen 0. N plus 1 is the rule. Peak will be singlet. Look like that. Neighboring 1, peak will be doublet. Will look like that. Ratio is 1:1. 1:1 means same height. Neighboring 2 hydrogens will be a triplet. 1:1:1. SS नहीं है, कुछ भी उनको बाद वालों को अपडेट किया. है और उनको अपडेट कर देना किस क्या टाइमिंग और एवरीथिंग. A2 का है ना टेस्ट. A2 का है जो खुद ही कर दिया तुमने. लिख लिए. If they're neighboring three hydrogens, so it's going to be split up into four parts known as quartet. Four is going to split up into five part known as multiplet. Five, six part multiplet. After four, you always call it multiplet. Multiplet. No, just leave them. Yeah. Okay, next. Let's have some practice. इससे ज्यादा की हमें जरूरत नहीं है ना. Done. Okay, now let's have few examples here. Pay attention. Okay, pay attention, बच्चों. Here it is a compound. Please use the data with the data booklet. What about this? How many peaks? One. Okay. How many peaks? One. Okay, and what will be the chemical shift value? जितने अनचेक्ड हैं वो अलग बना के देने कर लेते. कितनी peaks होंगी? There is only one peak for these six, 0.9 to 1.7. And what will be the splitting pattern? 6 plus 7. 6 plus 1. Splitting pattern. Neighbor has only one proton. Yes, it's going to be a doublet. What about the next peak? This one will be another independent peak in the range of what chemical shift value? Next to O है ये. Please check the data booklet. Next to O. Because both CH3s are contributing to one peak and the neighboring carbon has how many hydrogens? So you have to just add one number to the neighboring carbon, hydrogens. Okay. So what is the chemical shift value? 3.2 to 4. And what is the its splitting pattern? Multiplied, because 3 on right side, 3 on the left side, total 6. One above is not interacting. Oxygen with hydrogens, they are blocked. So 3, 3, 6 plus 1, 7. But we call it, वैसे तो इसको heptet बोलते हैं, but we call it multiplet. What about this? Another peak? 0.5 say 6, and it's going to be a singlet, unfortunately. No one is interacting. Zero neighboring. 0 plus 1 is? Rule is neighboring plus 1. Okay? Neighboring proton plus 1. So zero. As I said, it can't interact with. Aris, I said if I write this hydrogen, for example, here. So what I'm trying to say, कि the oxygen के साथ जो hydrogen attach होता है, it's blocked. It can't interact with the protons underneath because of the blockade created by oxygen or nitrogen. Okay. Next, number two. Please give it a shot. Quickly, you have to do it with me. Please draw this molecule with you. How many peaks? And then बोलना नहीं है, please करके देना है. Give it a shot quickly. And the splitting pattern as well. How many peaks? How many peaks? Seven peaks. Hashim said. Hashim, can you tell me which ones? 10 peaks. 10 peaks. Which one? These three hydrogens are going to produce three peaks. One. But if you look at this Hashim, this CH3 is attached with the C. Don't you think this CH3 is also attached with C and look like the same carbon? And what about this? They look like the same. So all CH3s, they are same in one type of chemical environment. So they contribute to one peak. So one peak. There's only one peak. All these 9 hydrogens contribute to one peak. And what will be the chemical shift value, Aries? 1.7, because they are alkanes. Okay? All hydrogens, all CH3s, they are attached with one carbon. तो neighbor होता है कि environment होता है कि who is in the neighbor. तो उनके neighbor में कौन है? Carbon है ना? So they are the same. Right? So therefore they contribute to one peak. और value वो data booklet से copy किया 0.9 से 1.7. And what is the singlet? Why? Because neighboring में there is no proton with the carbon. And what about this? It's aldehyde, right? So aldehyde is again singlet 9.3 to 10.5. And why singlet? Because it is attached with CO, so it can't interact with anybody else around. Here, G. Please draw the peaks for this.
सर आप एक साथ पीछे वाला दिखा सकते हैं?
Just 1 minute. Okay, the next one is here is the next one. G. Sorry for the delay. Okay, here. Number 70. This is number 7, which you have to tell me. Two peaks? Why two peaks?
Because C double bond O and H makes both of them makes one peak and CH2 and CH2 makes the second peak.
Okay, can you tell me the chemical shift values and their splitting patterns?
So C double bond O will have 9.0 to 13.0.
And they'll be the singlets? Both CWH, you are right. Both CWH are going to have one peak in the range of 9 to 13 chemical shift, and they'll be the singlets, right? So if I highlight them, so what you are saying, this CWH and this CWH, they will contribute to one peak, and they'll be the singlet peak, and range will be somewhere between 9 to 13 chemical shift value. Because here, look at this. The chemical shift value for carboxylic acid, look, it is given 9 to 13. Okay, so here it is. Okay, and similarly, what about these two? Are they going to be the same peak for these four hydrogens? And in what chemical shift value range? Is this CH2 very next to C double bond OOH? And this CH2 is also very next to neighbor of COH, but hydrogen is attached with the carbon. In the data booklet or the data given to you, the hydrogens attached with the carbon, you see they are given on the top, right? And the one that is next to C double bond O is here. It is what? 2.223. Can you see that? 2.223. So their range is, for these two, is it 2.223? And what about their splitting pattern? It is going to be a singlet, because they'll be collected together, na? They are taken together. So they are contributing to one peak. Na? So you can't say they are the neighbors of each other. They are in one house. So their neighbors are CWH. So they are going to produce a singlet. Okay, so two singlets, one in the range of 2.2 to 3, and other one is the range of 9 to 13. Okay, what about this number 3? Bacho, please give it a shot. How many peaks? Now, one by one, I'm going to ask you. Any volunteer? One peak of S, you said? Hashim said 2 peaks. Lelma? One peak. Mr. Aziz? Ayla Aziz? Are you there?
G, sir.
How many peaks in proton NMR spectrum for these CH3, CO2, CH3? It's an ester.
So shouldn't there be one? Because
Both methyl are looking like same.
G, they're in the same environment.
Okay, I hope you will change your mind if I draw the structure of ester like this, or you're not going to change your mind.
Sir,
Are you
isn't
still going with the...
Shouldn't there be two then? Because the oxygen is blocking. Nee, but oxygen to tab block करता है जब oxygen is directly bonded with hydrogen.
No, it's just splitting. But now if I have drawn the structure of ester a bit more explanatory, still you believe there'll be one peak? Lalmai, are you going to change your mind? You said one. Still you believe one? The methyl that is next to the oxygen is in the same environment. Obviously, the neighbors, the environment, won't it affect? Wes, have you changed your mind? So yes, 2 peaks. Because this CH3, which is next to oxygen, look, they are going to give peak in what range? 3.2 to 4. So their chemical shift value is going to be somewhere between 3.2 to 4, and it is going to be a singlet. And Lelma, look at this. CH3 next to CO, 2.2 to 3. This one. This is the singlet again. And this is 2.2 to 3. Okay? Because this is next to C double bond O. Okay? And this is singlet again. So these two peaks. Ayla, are you clear now?
Ji, sir.
Okay, next one. So I may be targeting you for a while now because of your wrong answer. Here, number 5. How many peaks? 2. Aris? 2 peaks. Lelma?
It's an ester, right?
Sorry?
It's an ester, right?
No, it's a carboxylic acid. Hashim? Ayla? Musa? Ayla, are you there?
2 peaks. 2 peaks.
Ji, sir.
How many peaks? Okay, let me write the open structure for this. HCOOH. Now, what do you think? I think it's clear now. 2 peaks. One of them is the carboxylic acid wali. वो कितनी है वो नीचे जाके देखनी होगी. Yes, 9.0 to 13. You see, which I just marked here. So this is 9.0 to 13. No, this is HCO. ये वो aldehyde वाली होगी. If you look at this, it look like, you see, it's an aldehyde. HCO. Look, this is the one. See? Doesn't it look like the same exactly? No, R doesn't make difference. The H that is attached with CO. This is the H that is attached with CO. So what is the value? Okay, but both of them are going to be singlets. Aisha, splitting के लिए आयला हमने देखना होगा. For the assigning of the peaks, you have to see their neighbors. Okay? For the splitting, you have to see what blocking and what not blocking. Okay? Are you there?
Ji, sir.
Okay. Number 4. Number 4, Aris. Lelma. Hashim. Can I just ask you to put your phone away? Okay. How many peaks for COOH? Hashim 2. Okay. Musa. Ayla.
1 peak.
1 peak. Ayla.
Sir, 1, because same environment. So.
Yes, absolutely same environment for both of them. Right? Both of them are carboxylic acid with the same neighbors, with the same environment, and they'll be range of 9 to 13 and would be a singlet. 6. 2 peaks. And range? 9 to 13? 0. No, that's wrong. CH3, which is next to Aries, C double bond O, how it could be? Yes, look at this. Look at this. Here it is. CH3 next to C double bond O. Look on the right side. So that should be 2.2 to 3. So this is 2.2 to 3. And it would be a singlet. Okay. Next is, what about this compound? What about this? This one. Aries. Relma. This one. No, that the one. The black one. This one.
Yes,
Ira. Ayla, are you there?
There are three?
3 peaks. Why?
3 environments?
Musa.
4 peaks.
4 peaks in proton NMR spectrum. यहाँ से भी किसी ने 4 कहा है? 3 भी कहा है? Yes. Okay, now I'm going to draw the whole structure. Lelma, you said 3? Okay, so here is the whole structure. This is CH, having 2 CH3s attached. And then this is CH2, and this is OH. Now, Ayla, do you still believe it's going to be 3 peaks in a proton NMR spectrum for this compound?
Sir, 4.
4. For these 2 CH3s, 1 peak होगी. मुझे इसकी रेंज बताएंगे? Alkane या next to alkane? Right side पे there is a table given. ये जो कार्बन के साथ हाइड्रोजन अटैच है वो सारा ये given है right side पे. Can you see?
0.9.
Yes. ये सारे जो है ना यहाँ तक they are the ones which is attached with the carbon here. No CH3 or next to CH3, 0.9 to 1.7. दोनों की एक पीक होगी और 0.9 से 1.7 की रेंज में होगी. What about this? और नहीं, आयला इसकी स्प्लिटिंग क्या होगी? What do you think about the splitting? Ayla, what will be the splitting of these 2 CH3s की peak? For the splitting, Ayla, you have to see their neighbor. CH3s को नहीं देखना है, इसके neighbor को देखना है. What about the neighbor?
So there's one neighboring hydrogen.
Yes, so उसमें एक ऐड कर देना है. Rule is n+1.
So doublet.
Yes, it's going to be a doublet. Environment का मतलब उसके neighbor हैं. Hashim?
Sir, neighbor clean बनी थी
दोनों CH3 का एक नेबर है.
देखो
एक नेबर है तो दोनों का एक जैसा नेबर है, तो एक पीक होगी दोनों की.
टोटल 3 पीक
आते हैं ना उस तरफ. पहले अभी इसकी तो एक पीक हो गई ना दोनों CH3s की, और डबलेट होगी. ओके, अरीज इसकी एक अलग पीक होगी CH की, और ये भी 0.9 से 1.7 होगी. अरीज, कैन यू टेल मी द स्प्लिटिंग ऑफ दिस पीक? For the splitting, you don't have to look at Ayla CH. You have to look at its neighbor. This time there are 3 neighbors. 3, and 2. 3, and 2. So how many in the neighbor? 3 plus 3 plus 2 is what? 8. 8 plus 1? 9. So CH ki peak would be a multiplet. Ayla, are you clear now how to look at the splitting?
Ji, sir.
Okay, next. Okay, again, this CH2 is going to be a different peak because was absolutely, and it will be in what range? Because this carbon is attached with oxygen. So here it is 3.2 say 4. You see? So 3.2 to 4. 3.2 to 4. And what is the splitting pattern? Neighbor में एक है. Yes, so it's going to be a doublet. The last but not the least, OH. 0.5 से 6, and it is always a singlet splitting pattern. और why 0.5 to 6? Because ये alcohol की peak है, वो देखिए नीचे. This is the one. और आइला OH NH के साथ जो हाइड्रोजन अटैच होते हैं, their peaks are not splitted. I did. Yeah, I already did. Check the group. Yeah, the whole notes are there.
सर मुझे साइन करना समझ नहीं आ रहा किस तरह साइन करें ग्रुप्स को वैल्यूज के साथ.
Don't get it? मैं अभी कराता हूँ एक और. Did you find them on the WhatsApp? They all are there. Okay, you just zoom in, scroll right, left, up and down, so you'll find everything. They may be little bit, not maybe surely bit messy, but you'll find your answers. You will find all the information, okay? How many peaks for this? Sorry? Three. One. Sorry. One, two, three. Okay, starting from you, Ayla. What will be the range of this and splitting pattern for this CH3? Three peaks in NMR, proton NMR spectrum for this compound, Ayla. What will be the CH3? Ayla, are you there?
जी sir.
Okay. CH3
Will
है, पहले केमिकल शिफ्ट वैल्यू बताइए. खुद भी एल्केन है, नेबर भी एल्केन है.
so 0.9 to 1.7.
Well done. Good job. What about the splitting pattern? For the splitting pattern, you don't have to look at CH3. Look at its neighbor.
CH2 or the two hydrogens to triplet.
Good job. Next, Mr. Aris. 2.2 say? Why? Because this is next to CO and next to CO is here. Okay? It is 2.2 to 3. Can you tell me the splitting pattern? On the right side, nothing, C double bond O, but on the left side, there are three hydrogen. When there are three hydrogen, 3 plus 1, quartet. So whenever there's a quartet triplet, CH3, CH2 साथ होते हैं. Okay? What about the last? Amide. 5 से 12. And obviously would be a singlet.
How many number of hydrogens we take for the not sorry, multiplet?
4 above. Quartet is the last one which we name. Otherwise, pentet, hextet, heptet, but we don't name them. Okay, next. What about this? How many peaks? Musa.
3 peaks.
Ayla.
Sir 3.
3 peaks. And for these two CH3, क्या range होगी? 0.9 to 1.7 and would be a doublet. For this, sorry?
That's 2.2.
Next to oxygen है, so 3.2. Next to oxygen है, ये वाली है ये. Yeah, next to oxygen. So this should be 3.2 to 4 and should be a multiplet. Why multiplet? 6 hydrogen है, so it would be a 7 parts में broken होगी. And OH we know 0.5 to 6. Okay, we'll continue this. We'll have some exam questions tomorrow. Thank you for the joining. Allah Hafiz.